multiplication, but remember yesterday we kind of left our heads scratched. Like, is this multiplication or real multiplication today? So Miss Lovelace and I were talking, and we found these pictures, and so here's what I want you to do. I want you to look at the models on the screen, and I want you to turn and talk. What do you notice about them, and what do the models represent? Turn and talk with your neighbor.
There's two at the bottom.
So, are you talking about the first picture with the circle? So what do you see? Like, how would you describe that picture? Okay. What can we call this? Okay, so how many are there? What does that represent? And then see, relate that to the second. How do you know? Okay, what about the second? Well, wait a second. Did you say 3 groups up? Super focus. All right, so tell me, what did you notice about the two models on the screen? Great. Say it loud and proud now.
One model had 3 groups of 5.
Okay, which one? The top one or the bottom one?
The top
Okay, 3 groups of 5. I'm with you.
and the bottom one had 3 groups of 6. I mean, it had 3 columns.
3 columns. Which way do columns go? So we have 3 columns going this way? 3 of them? Let's count them. Help me out. How many?
1, 2, 3, 4, 5, 6.
How many columns do we have?
6.
6. Okay, and there are 3 what?
3 rows.
There's 3 rows, but wait a second, you started to say groups. Because do we see that there's 3 groups of 5 on top? How do you see groups? Where are the groups? The circles, right, Trey? And what's inside of the circles? 5 in each, okay? But let's look at the bottom. Are there groups in that array? Where do you see groups? Because there's dots, but there's no circles there. London.
The 3 rows, I can kind of see it as if you circle one row with columns.
Okay.
The number of columns, that could be a group, like 3 groups of 6.
I see. So circling the rows.
Yeah.
So how many groups would we have if we circled the rows? 3. How many would be in each? 6. Okay. Kayla? You could circle the columns too? How many columns would there be then? 6. So now how many groups would we have? 6. And how many would be in each group? 3. Could I do that for the top? Is that 5 groups of 3? Why not? We did it for the bottom. There's not 5 groups? How many groups are there? There's only 3 groups with how many in each? 5. So you're telling me for the top one it matters, right? I can only say 3 groups of 5 or 3 times 5. But the bottom one could be 3 groups of 6 or 6 groups of 3? What about our equations? What do they represent? 3 groups of 5, we could also say that as what? 3 times 5. 3 means the groups. 5 means the in each group. Equals would be what? The total. The total of what? How many shapes are there altogether? How many are there altogether? 15, right? The bottom one, what can we say? So if it was 3 groups of 6, what would our equation say? 3 times 6. 3 would be the groups. 6 would be the number in each group. Or, you told me we could do commutative property, 6 groups of 3, or 6 times 3. I've got you. Okay, so I want you to keep this in the back of your brain today, because we're going to do a problem, and I wonder if we'll see this again. Can I get Miss Hager, will you be my clicker?
That's kind of dangerous.
Just press an arrow. I think so.
Nope.
Or try the right arrow on the keyboard, maybe. There we go. You got it. Thank you. Okay, let's look at our goals for today. What we're going to be working on. Repeat after me. I'm learning.
I am learning
To interpret a multiplication equation.
to interpret a multiplication
As a comparison statement.
as a comparison statement.
Back that up for a second. Interpret. What does that word interpret mean? I'm learning to interpret a multiplication equation. What does that mean? Where have you heard that word interpret before? Elmer, can you think about it? In a show you've seen interpret before? Maybe. I'm thinking about science. Sometimes it tells me, like it gives me something, and it says interpret this chart or interpret this map in social studies. What would that mean? They said interpret this chart or interpret this map. Say that again. Understand. Figure out what does it mean. So we want to figure out what a multiplication equation means as a comparison statement. So remember at the end of yesterday we made that nice anchor chart. I put it on paper for you today. And you all told me we saw some problems that we thought were comparison. What does that mean, comparison? Same and different, similar and different. Okay, so we're going to be looking at some things that are similar and different and making some meaning out of them. So you're going to tell your parents tonight when you go home when they ask, what did you learn today? You're going to tell them that I learned what I could do when I could determine the meaning of a multiplication comparison. You're going to be able to tell them about this problem we're going to do today, and we're going to see if we can connect it back to multiplication, comparing some of those things. So let's review. Yesterday we did our card sort activity, right? Do you remember that? What did we find at the end of our sorting? Remember we all came together and we tried to make two groups as a class, and what did we figure out about those problems? Yes, Sid? Speak nice and loud.
There were some that said times that we haven't seen.
Yeah, there were some problems in them and they said times, right? We had other problems and they said things like what? They didn't say times, they would say things like what? There were 4 groups or 4 plates or 4 packages. You remember that from yesterday? So we saw some that was very clear. We're like, yep, those are groups for sure. But then we came up with, there were some that said times that didn't quite fit with what we knew just yet. So we're going to explore with that a little bit today. Let's think back though, go back in your 3rd grade brain or the beginning of 4th grade. What strategies have we come up with to solve and represent multiplication problems? Ruby. We made groups. What else? Emily. Ooh, decompose, what does that mean? Why do we break apart numbers? Make it easier, make it more efficient and smaller. Kayla. Arrays, for sure, right? There's one we learned this year in 4th grade. Area models, right? So we're going to see if we can connect all these pieces together and figure out what's going on with this last little part here. All right, you ready for your task? You don't seem ready. Are you ready for your task?
Yeah.
All right, here we go. Miss Haley, I need one more click, please. All right, raise your hand if you like Pokemon. I know Ruby's for sure a Pokemon lover. All right, so Diego and Elmer have got some Pokemon cards today. So we're going to look at a task about Diego and Elmer. There's a part about you, Ruby. I'm not leaving you out. We're just going to save you for next week, okay? All right, so when you're working today at your table groups, you're going to have some materials, and I want you to be building some representations for everyone to see, but I want you to draw them also because we're going to come back to these problems next week, and you can't put your tiles in your school bag and save them for next week. So we're going to draw a picture of what that looks like too. So here's what you've got to figure out. Are you ready? Elmer has 6 Pokemon cards. Diego has 2 times as many cards as Elmer. How many Pokemon cards does Diego have? Oh, I know some. Look at that. Some of y'all are like, I know already. Shh, don't tell us. So here's what you're going to do. When I dismiss you back to your table groups, you're going to need a pencil, and you will get a task that you're going to write on. You've also got some buckets that have some tiles on them that you can use to represent, and you've got some dry erase boards and markers you can use as well. I want you to build for me, what do Elmer's cards look like, what do Diego's cards look like, and how do you know? Got it? Go.